I'm now going to move into the pitches. As I mentioned at the start, we have 5 minutes for each pitch, followed by 5 minutes of Q&A from the panel. So without further ado, I'm going to hand over to Dr. Nick Canopoulos from Brite, Hellas. You have 5 minutes, Nick, if you'd like to share your screen.
Okay, can everybody see it?
We can, Nick.
Okay, good afternoon. My name is Nick Canopoulos. I'm the CEO of Brite Solar. Brite is based in Greece. We are a team of 15 highly talented people who are all company shareholders. Our technology is patented and our management team has over 100 years of collective business experience. One of the global crises we are faced with today is the production of adequate food for the projected 9.7 billion people on the planet by 2050. Given that agriculture consumes 14% of energy and 70% of water globally, it is clearly unsustainable to produce the 80% increase in the needed food supply by conventional cultivation methods. The solution here is greenhouse cultivation, where we can increase 10 times the yield using 10 times less water at the expense, however, of using 10 times more energy. Our company focus is in solving the energy consumption problem in this sector. The solution is a transparent solar panel with uniform spectral transmissivity, as you can see here. And this is done through a nano coating material on the panel, which absorbs UV light, which is useless for both plants and solar cells, and retransmits it in the red region of the visible spectrum, which increases the photosynthetic active radiation by about 3% for the plants and increases the solar cell efficiency by 10%. This is the diagram down here. And this yields essentially the best transparent PV panel in the industry for greenhouse applications and protective structures in open field agriculture. The value chain we have developed in order to deliver the product in the market is we take and coat the glass and work with an OEM manufacturing partner in China who finishes the end product and ships it to the ordering customer. We have this process in place now. We deliver a low risk, scalable to any volume required technology at an attractive cost. Our material has been going through accelerated life testing as we speak. The coating line is being set up with off-the-shelf tools, and our OEM partner is a tier 1 PV manufacturer. We run a high yield process in order to keep the cost down. This is the design of the coating line. We have finalized the list for the factory space required to install the line, and we have identified off-the-shelf tools that can be used to realize our line design. We have also deployed the product in a pilot greenhouse installation in Greece with some exciting results so far. This will be the first time in Europe where a vineyard will deliver 2 crop cycles within the period of 12 months. This is the dashboard that shows the real-time production of electricity of the panel and also the money savings. Right now, the produced energy drives the cleaning of the winery where we are installed at. The total cultivation land for greenhouses is 33 billion square meters today. However, most of it is with plastic cover. The glass greenhouses, our service addressable market, occupy 180 million square meters, and the market performs at an 8% annual growth rate. Based on this data, our SAM is estimated to be 7.2 billion right now. We have already market traction, and our focus market is the Netherlands, both for greenhouse manufacturers and operators, and we anticipate product sales in 2021. We focus on the Netherlands because the 61 Dutch greenhouse manufacturers make 85% of all glass greenhouses delivered worldwide. So by addressing the Netherlands, essentially we address 85% of the world market. This is our revenue model, where we project revenue exceeding 100 million in 6 years and break even in 2022. In terms of fundraising, we have The seed funding for the company was provided by me, the founder, and then through R&D contracts, we raised 7 million, and we closed Series A with the European Innovation Council at 4.2 million. Now we are in the process of starting the process of raising Series B at 20 million, which will be used primarily for CapEx, for setting up the large scale production, for a little bit of operating expenses, for setting up the sales and distribution channel, and build initial orders for the market. Thank you.
Thank you very much, Nick. You were bob on time. Over to the panel for questions. Susanna, Plassey, and Henry. Who would like to start?
I can start if that's okay. I've got a question about, that was a great presentation and with a lot of detail, especially on the panel itself. So my first question is, you have the patents of the panels, and where have you patented them?
Okay, we have filed 2 patents in China.
Okay.
And we will, in the next 2 to 3 months, we will be filing in Holland and the US.
Okay, thank you. Susanna?
But certain aspects of our technology, the material deposition method, which is inkjet printing, which is something unique to what we are doing, has been patented before.
Okay, so you just
already
using
existing patents on the material deposition method, but here we are patenting the composition of the nanostructural material for the coating.
So the makeup of it,
right?
Not
And
the coating itself.
The company has a total of 8 patents, both granted and pending.
Okay, thank you.
Hi,
Susanna?
Nick. Yeah, thanks very much. Hi, Nick. Thank you for your presentation.
Hi.
I actually saw another company this week making a coating for greenhouse target in the Netherlands. So it's obviously quite a popular space. And I wondered what makes. Sorry?
I know the company is called Fize. It's from.
It wasn't actually, but what makes your technology better than the others that might be available in the market, and how does it compare on a cost basis?
It makes it different. The material, because we know what the competition does, and in that case they are not shifting UV, they are shifting part of the visible spectrum to a different part of the visible spectrum that is closer to where the plants photosynthesize. The nanostructural material is different composition. The material deposition method is different, and we actually have applied it in a real product. Plus, we are finishing up our life cycle or accelerated testing for the material, because finding a material that operates in certain ways and making a product with it are 2 different things, because most of these materials have problems with long exposure to solar radiation. So we've got to make sure that they don't degrade over at least a 20-year period.
So there's a better performance from the materials. Is that the key differentiator?
Yeah, and in our case, these guys want to shift the spectrum only on regular glass only for the plants. We want to shift the spectrum and gain also efficiency in the solar cells. So we make a solar glass. They make a glass that has more transparency than regular light. They're two different products.
Okay, thank you.
And Nick, I have a quick question.
Yes.
Can you just explain to what extent does your technology get deployed as retrofitting existing installations of greenhouses, or do you actually require new installations for your technology to be deployed?
That's a very good question. Actually, we can go into any installation because the thickness of our glass is between 3.8 and 4 millimeters, which is the standard glass used in greenhouses. However, if you mean to apply the technology on glass that existing greenhouses without replacing it, the answer is no. So we can go to an existing greenhouse structure by taking the old glass, throwing it away and replacing it with solar glass.
It seems to me that there's quite a large market for greenhouses, but it's already quite established.
Actually, to be honest with you, the market that it is far greater is what we call agri-PV, which is dual-use land, where we essentially install crop protective structures in open fields. In other words, think of a parking lot structure over a field that they cultivate apples, oranges, whatever, to protect them from the elements, and at the same time produce energy. And there are some very interesting business models there, because there are people who want to deploy PV in countries, for example, take Holland, where land is scarce, and they make the value proposition to the farmer, okay, we're going to protect your plants, but we are going to sell and make the revenue from energy sales. So
thanks,
the farmer
Nick.
wins, the PV guy wins, and everybody's happy, I guess. That market is much larger than greenhouses.
Thank you, Nick.